Chapter 13, Section 4, Artificial Neural Network. This section covers what an artificial neural network is. An artificial neural network is designed as an imitation of a neural network in our brain. It mathematically models the function of a brain's neural network. An artificial neural network consists of connected nodes. Its structure is almost the same as that of a multi-layer perceptron. The nodes in the left end receive the information. Then, the information will be transmitted from the left nodes to the right nodes. Finally, the right-hand node calculates the output. The neural network has a hierarchical structure consisting of multiple layers, and each layer consists of one or more nodes. In an artificial neural network, the first layer is called an input layer, and the last layer is called an output layer. The layers between the input layer and the output layer are called hidden layers and middle layers. In this example, there's only one hidden layer, but an artificial neural network can contain more than one hidden layer, such as 10, 100, and even more. An artificial neural network can be used for both regression and classification. That is, an artificial neural network can be used to predict both numerical values and categories. Similar to a multi-layer perceptron, each edge has weight values that determine the impact of inputs. Here, they are represented as W1, W2, W3, and so on. As with the case of a perceptron, there can be biases, but this example does not contain biases, just for simplicity. Suppose each edge has these values of weights. And suppose the network receives two input, 10 and 20. Then, the inputs are transmitted to the next node. In this process, the inputs are multiplied with each edge's weight. Then, sum up the product of weight and input. Those values will be the input to the hidden layer. Then, the values are transmitted to the next node. In this process, the values are multiplied with each edge's weight, and then summed up. This is the output value. That is, if we input 10 and 20 to this network, the network outputs 16.4 as the predicted value. Up to now, we have seen a neural network that has only one hidden layer. An artificial neural network that has two or more hidden layers is usually called a deep neural network. As we saw in a neural network, the calculation proceeds from the input layer to the output layers. Each edge has its weight. If we pass the input values to the input layer, the product of the input value and the weight will be passed through. Then, these products are summed up in each node. Then, same processes continue. Finally, we obtain the output value. This process is called forward propagation. You may think that the calculations are complicated. But taking a closer look, we can find that the output is simple. Let's look at the expression of the output layer. It implemented multiplication 2 times, so it seems a bit complicated. But it can be transformed into a formula that expresses the linear relationship between x1 and x2. So, the neural network expresses x1 and x2 as a simple straight line. These kinds of simple formulas can predict only simple relationship between the features and the output. So, a neural network applies a nonlinear transformation to the middle layer to deal with problems that require more complex calculations. So, functions called activation functions are applied to the outputs in the middle layers. That is, activation functions are used to apply a nonlinear transformation to the middle layer's outputs. By stacking middle layers transformed by activation functions, a neural network can implement complex calculations. There are various types of activation functions. Step function is a type of activation function that is used in a perceptron. It returns 1 when the input exceeds 0, and otherwise returns 0. Sigmoid function outputs values ranging from 0 to 1. As the input gets larger, the output approaches 1. The output value of a sigmoid function changes continuously with the change of the input value. Tan function is an expansion of sigmoid function. It is also called hyperbolic tangent function. Its output ranges from -1 to +1. A few more. ReLU function returns the same value as the input value when the input exceeds 0, and otherwise it returns 0. Identity function returns the same value as the input value. These are the popular activation functions applied to a middle layer and output layer in a neural network. For a middle layer, step function, sigmoid function, tan function, and ReLU function are used. For an output layer, identity function, sigmoid function, and softmax function are used. When we apply an activation function to an output layer, our purpose is to make the output value the appropriate form. When we use a neural network to a regression analysis, we apply an identity function to the output layer, because identity function returns the same value as the input. On the other hand, when we use a neural network for a binary classification problem, we apply sigmoid function to the output layer, because sigmoid function outputs continuous values ranging from 0 to 1, and thus it represents probability. When we use a neural network for a multi-class classification problem, we apply a softmax function to the output layer. Softmax function is a complex function, and its mathematical explanation is beyond the scope of this course. But let me tell you, softmax function is applied when we use a neural network for multi-class classification. The difference between a multi-layer perceptron and a neural network lies in the difference in activation function applied to the output layer. While a multiple perceptron uses step function as the activation function, a neural network uses other activation functions like sigmoid function. A step function is a discontinuous function that only returns two values, 0 or 1. On the other hand, a sigmoid function is a continuous function that can return every value between 0 and 1. This is a meaningful difference in the application of a neural network. Let's summarize the points in this chapter. Deep learning can overcome some limitations of machine learning, such as curse of dimensionality and manual feature extraction. Perceptron is a model that simulates the neural circuit of the human brain. It can classify data linearly, but it cannot create a non-linear logic gate such as exclusive OR gate. A neural network has a hierarchical structure consisting of multiple layers, and each layer consists of one or more nodes. While a multiple perceptron uses step function as the activation function, a neural network uses other activation functions like sigmoid function. Thank you for watching. Please thumbs up and subscribe to my channel.